So now some of the things which we have done over past, I think last couple of years with our teams have been implementing the technologies like Snowflake, and also some of the other technologies, whether it's DBT or Medallion or Fivetran, or data observation tool like Monte Carlo data. There are always certain tricks and tips, and it's very hard to really hone into each of those components. So we're just going with right now in this session, we're going to talk about some of the things which we have seen and what have been successful for us. This is over the best practices which we have built over time after implementing many solutions, right? So today we are focused on Snowflake, but eventually we are going to get to a point where hopefully we can talk about other tool sets, and including data mesh and future sessions. So the first thing what we believe in, especially the first point, whether it is Snowflake or not, what we have seen is in the modernization effort, it does become important to really focus on your data model. And data modeling has been there for the longest time, right? I mean, we all know that data models are critical. And it's not just initially, I think 10, 15 years ago, outside the business use cases, one of the key areas was that how can we eliminate most of the joins, because we were working on older technologies which were built for OLTP like Oracle and SQL Server, and very, very focused on that. So the star schemas and integer joins with the surrogate keys and all dimensional models, they were very successful, and they still have a lot of value in today's time. The only difference now is that more than technology like Snowflake makes it very easy for you not to really worry about a lot of those things which we worried about for query performance. That is what the beauty of what we have seen. So when we are designing the data model, when we are putting it together, we are more focused on designing it and modeling it in a way that it is more geared towards business use cases rather than trying to see whether this is going to perform or not. A lot of that does come out of the box from Snowflake, and that's the beauty. That's one of the beautiful things which we have learned over time, that focus on the data modeling, whether it satisfies the business requirements, whether it's BI, whether it is ad hoc query and whatnot, right? So that's one thing. And now, whether somebody's using dimensional model, that's perfectly fine. But one thing I do want to mention here is that the data vault model having in front of the dimensional model has really paid large dividends to our customers, because dimensional models can generally end up, you may want to rebuild them, and you don't want to keep going back to the source. The links are already there in the data vault. So a combination of data vault and dimensional models is what we see a lot of success out there on Snowflake. So that's one of the things which we have learned from the database design perspective. Setting up different databases now, especially given the sharing of the data or the sharing of the database across multiple. So, for example, if you have reference data, rather than have that reference data which needs to be used across multiple departments within the organization, now because we are on the cloud and because we have a database technology like Snowflake, where you can actually have the decoupling of the storage from the compute, you can actually share the reference data across many, rather than copying it and creating the replicas of it. You keep it once, and you can actually have it across many other departments or the data marts within the organization. So setting up the database design becomes, and that of course goes into how do you set up your role-based security, RBAC models, multi-tenancy, all of that plays into it, and it becomes a lot easier. So the database design part of it is also very focused on the business side now rather than the technical side. The other thing which we all know that, with decoupling the storage and the compute, and also taking the elasticity of the cloud, this is an important, very important, aspect which we have seen successfully, and that is that we are able to now go into customers and say, okay, when you're running something critical or not even critical, like for example, I may be running my ELT and using the power of Snowflake, and I say, okay, I'm running on an extra small cluster, but I want to bump it to medium for the same, or I want to shut it down. I want to dedicate one particular virtual warehouse for processing, quant queries in the financial services early in the morning. That kind of scale up, scale out scenarios are much easier, and we're looking at few seconds, not that we need to have somebody call and then IT takes over. It takes a few days or hours to be able to do it. So that's a very critical feature. Now implementing that will depend on the use cases, obviously. The last thing about the self-service and the analytics, that comes because of the key features which are built into the optimizer planner of Snowflake. So old days, where you had to pass a lot of hints to make the queries work. Unfortunately, self-service was never almost impossible. They were always dependent on a lot on the ID staff to tune the query or put the data in a certain way, create a materialized views and whatnot. Now, I'm not saying that Snowflake solves all of this completely, but what we have seen is that ad hoc queries and you being able to go in and say that, hey, I just want to run some certain deep analytics on the data. It does make it a lot easier without having the dependency on the IT all the time. Is it 100%? Probably not, because it also depends on the tool set which is being used for the self-service outside Snowflake. But what Snowflake is empowering is that you can actually go in and you can say, I just want to ask a question of the data and expect for the answer to come back in a reasonable time. For the ETL and ELT, we are completely focused on ELT, and there are a couple of reasons for that. One is that you're already buying something which has parallelism built into it, right? So something Snowflake which already has scalability which is built into it. Why not use that? The second, the data movement. If you want to do ETL, the data movement of large data sets, from bringing it out from the database and pushing it into ETL tool for lookups and whatnot, that becomes expensive. So most of the tools anyway today, the traditional ETL tools also, they have the capability to push it down to something like Snowflake. So you can easily push it down using ELT approach, and use the normal SQL. SQL is very powerful. It has a tremendous amount of, rather than doing lookups, for example, you can do joins, do set-based operations versus row-by-row operations. So all of that comes out of the box with something like Snowflake. Now, these are some of the, what we have learned, not, although we mentioned Snowflake, but what we see is that this is our based on our reference architecture, that's what our best practices are. So this is over few implementations with some of the large corporations.